this is the basic outline. So we will talk about the fiber. First of all, we talk about the fiber, and then the transmitter. So this is the source, okay, including some different type of lasers, some laser dynamic. Okay, this means for example, let's say we will modulate the laser on and off, right? On and off. So we will study some modulation format like using direct modulation or external modulation. And finally, and then after this, we talk about the receiver. So transmitter, fiber, receiver, and then some network equipment, okay? Something like this. So the flow of the lecture. So last time we talked about, if you want to do a project, so I give you some suggestion, right? First of all, this is our course textbook, okay? If you're a local student, maybe you understand Chinese, so you can read my book, or two other textbooks. This I think is very good. Okay, one of them is from Agago. Okay, this one. Now this is the fourth edition. Okay, the new edition. But you can borrow the second, the third edition in the library, right? So this is very famous book about the optical communication. And also I also found one new book. This is with plenty of example here. So this book is also very good. Okay, from Karma. Okay, also from Winey, okay, to Winey. Okay, so they're also very good. So you can have a look. Now, last time we also suggest, I also tell you about how maybe we do a research, okay? First of all, we can look at the textbook, but the textbook is, the information there is quite old, right? Out of date, because it is not new enough for you, okay? Then maybe you can select some journals. So last time we talked about some ranking, okay? Ranking, we can arrange the journal and according to their impact factor. Okay, still remember, right? According to the impact factor. So let's say I just give you an example. Like for example, the Optical Express, okay, is ranked the 6th, and the impact factor is about 3.5. Okay, something like this. Or you can also look at the conferences. Right? This is more new. Okay, it gives you some more detail for the state of the art. So let's say the OFC, right? The ECOT, and some in the Asia Pacific is the ACP or the OECC. Okay, so this is just some example we discussed last time. Okay, now we also talk about. Okay, so we start from here. So for the optical communication, including several elements, right? The three important elements is the laser, fiber, and because optical fiber communication, right? So this is the fiber and the photodiode. Now, for the laser diode, it changed the electrical signal to optical signal. So we usually call it EO. And here, from optical to electrical, we call it OE, okay? So people may usually say, maybe you know this, OEEO, right? Or OEO, okay, something, this is talking about like this. Okay, this means you transform the signal from the electrical domain to optical, and then to the fiber, and then to the OE. So now for the chapter 1, I will give you some story, some history about the, maybe you remember some famous name, okay, for the optical communication. So the first one is the fiber, right? Last time we talked about Professor Charles Kao, okay? He invented the fiber, okay? Anyone still remember the year? Anyone still remember the year he first published his paper about the optical fiber? Any idea? It's in the you should know, right? Do you know? No? Any suggestion? Okay, very good. Okay, 1966, okay, 1966. Okay, because last week we talked about, at that time, many people were focused on the microwave, right? They designed the RF component, okay? But at that time, no one think optical communication is important, okay? Because this is very new. Okay, at that time, so I think this is last time we talked about, we have a photo in 2005, and this is his Nobel Prize Award. Actually, he donated this award to the Chinese University of Hong Kong. If you visit Hong Kong, okay, you can go to the library, okay? Go to the library and this is open for the public. Okay, you can see this is some exhibition. Okay, about his life and about some medals. Okay, he donated to the university. So, okay, so this is the first one we talk about is many people at that time. Okay, this is from the Nobel lecture. Many people at that time they're talking about radio communication, millimeter wave, okay, mm wave. So at that time, this is very mature, and but the cost is very high. Okay, so people will think that okay, if we can use optical communication, then this means we can have a higher capacity. Okay, so this is a comparison. Okay, at that time. Now, so one more things. Okay, we discussed last time. So what is the main contribution by Professor Charles Kao? So, Professor Charles Kao suggests, okay, this is his paper. Okay, so he suggests we can use the glass, okay, the silica glass. This is high transparent enough to transmit the signal, okay, to transmit the signal. So actually, at that time, okay, no one think about this. So he think that the dielectric fiber surface waveguide for optical frequency. Okay, so the glass can be transparent enough to carry the data. Okay, this is his main contribution. Okay, the first paper in Proceeding IEEE in 1966. Okay, so we and then 4 years later. Okay, 4 years later, Corning. Okay, Corning manufactured the world first low loss optical fiber for telecommunication. Okay. So we will come back later to here. Okay, so this is the tin dot experiment. You know, actually a long time ago, people know that. Okay, we can use some form of waveguide to guide the light. Okay, due to higher refractive index, lower refractive index, the light can be guided. Okay, can be guided in this kind of material. Okay, but Professor Charles Kao think that okay, we can use glass. Okay, this is his contribution. Okay, now, so okay, first of all, we know that we have the manufacturer. Okay, the first fiber in 1970, right? Okay, we have the laser in 1960. So we have a look. Okay, I hope after this course you remember 4 things. Okay, this is actually some important developments of optical communication, okay, starting from the first invention of the laser by Professor Charles Tang, okay, and then 1966 by Professor Charles Kao about the optical fiber, okay, and these are two important inventions, okay, and later on, in 1987, we will have the first optical amplifier, okay, I will go about it later. And then the fourth is the WDM, okay? And recently we have a lot of invention, okay? To achieve, okay, this increase in the capacity in the data rate. Okay, nowadays because you know, okay, I give you one picture, right, from the Japanese Internet Exchange. Right, this is the data rate, okay? So this is the year. So we can see that it's still increasing, okay? Why we can keep this data rate increasing? Because of optical communication, right? And why the optical communication still evolving, okay? Keep increasing because of several technologies, okay? Just we discussed, okay? So the 4 fundamental one actually is this 4, okay? Laser, fiber, optical amplifier, and also WDM. Okay, hope you can remember these four important developments. So the first one, I think all of you have the idea about the laser. So this is maybe you can we have two energy level system. So one of them is you can use electrical or you use optical pumping, okay, to pump some electron from lower energy level to high energy level, right? And then some photon goes in, it will trigger the electron at high energy level to jump down, so they will produce the coherent, okay, same phase, same frequency, okay, optical signal. So this is a kind of what we call laser, okay, light amplification by stimulated emission radiation. Okay, I think all of you know this, right? Okay, then, so this is Professor Charles Towns. Okay, so you can see here, okay, he received the Nobel Prize in 1964. Okay, then what is his contribution? Okay, so for the fundamental work in the field of quantum electronics, which has led to the construction of the oscillator and amplifier based on, anyone see this? Okay, this is not a mistake. Okay, this is a maser. Anyone heard about maser? Maser laser principle. Laser, you know, the L is the light. How about M? Maser. Good, okay, good. Because at that time, many people is working on microwave, okay? So they think that actually it's a kind of oscillator, but it can amplify microwave. If the frequency is different, then it becomes light, right? So it's a maser or laser, okay? So he's from MIT. Now, so, but unfortunately, okay, this is the news. Just some 2 months ago, right? He passed away. So at the age of 99. Okay, but it's quite unfortunate because you know this year is the year of light, right? This year is the some photo. If you are interested, you can go to your Google search. Okay, some of his wife. Okay, several years ago, he's still very active in different conferences. He will still give some keynote talk to the public. Okay, about the laser. Okay, so now, so you know the name Charles Towns. Okay, you know he invented the laser.